Welcome to Study Loop.
To determine if we can reject the claim that the machine is functioning properly, we need to perform a hypothesis test. So the null hypothesis would be that the machine is functioning properly and the standard deviation of the sample is less than or equal to 0.03 ounces. The alternative hypothesis is that the machine is not functioning properly and the standard deviation of the sample is greater than 0.03 ounces. To test the hypothesis about the standard deviation, we can use the chi-square test statistic, which follows a chi-square distribution. The formula for the chi-square test statistic for testing the variance or standard deviation is that chi-square is equal to n minus 1 times the standard deviation squared over the population standard deviation squared. So S squared is the sample variance, and sigma squared is the hypothesized population variance. So we're given that the sample size is 8, the sample standard deviation is 0.043. The hypothesized standard deviation is 0.03. And so first we'll calculate the sample variance. That's 0.0018. And now we'll calculate the test statistic. That would be 8 minus 1 times 0.0018. That would be the variance, which is S squared, by the way, over the hypothesized variance, which is going to be 0.03 squared. This calculates to 14. Then we determine the critical value. Since we're performing a one-sided test, which is right-tailed at a 0.05 level of significance, we need to find the critical value of the chi-square distribution table or using statistical software. The critical value for a right-tailed test with 7 degrees of freedom and a significance level of 0.05 is about 14.067. And now we compare the test statistic 14 with the critical value 14.067. If the test statistic is greater than the critical value, we reject the null hypothesis. Otherwise, it is barely, but 14 is less than, so we would fail to reject the null hypothesis. Well, actually, we would take the square root of 14, which is also less than 14.067, so we would still be failing to reject the null hypothesis.